Good afternoon, I am Mr. Ish. Thank you for joining me for this particular video. We are looking here at a comparison between two specific questions. They are very similar, but they're specific and different. Given a parametric equation or set of parametric equations, we have to find the representative curves. In all instances, our parameter here is this variable t. You know we have x, we have y, but then we have this third variable, the parameter t. The value of t is between 0 and 2 pi, and just by looking at that, you know t here represents an angle in radians. The value of t, an angle in rad rads. And this specific relationship here applies to both a and b. We're going to do a and we'll do b. When we're looking here at a, we have x is equal to a cosine 2t and y is equal to a sine 2t. These are two separate equations, parametric equations that have to be combined somehow to develop a rectangular equation only in terms of x and y with the t eliminated. How can you go about doing it? When you look at this part A, let's look at part A. Bring in each instance the a and take it across the equal sign. You'll have x over a is equal to cosine 2t. And then you have y over a is equal to sine 2t. And just before I get myself too far ahead, let me go again. Question A here is x is equal to a cosine 2t, y is equal to a sine 2t. Question B, x is equal to a sine 2t and y is equal to a cosine 2t. You can see that the trigonometric functions are switched in terms of x and y. Anyhow, back to a. X over a is equal to cosine 2t and y over a is equal to sine 2t. A good technique over here, square everything. It helps develop a relationship that you'll see. You'll have x squared over a squared is equal to cosine squared 2t. Here you'll have y squared over a squared is equal to sine squared 2t. When you're looking at this, you're thinking now of something which looks very much like a trigonometric identity, which you know sine square x plus cosine square x is equal to 1. But think about that trigonometric identity. It very much is related to the unit circle. It sure is, because you have sines and cosines involved. In this particular relationship with the squares, it'll always equal to a 1. And then when you're thinking about that in your head, you're thinking about a unit circle. Combine these items together. You're looking here at x squared over a squared plus y squared over a squared is also equal to, as you will see, cosine squared 2t plus sine squared 2t, but all of this should equal to 1 because this identity is always equal to 1. No matter what you have in here, in general, the identity is equal to 1. You can now just take this and combine them together. When you combine them, you'll have x squared over a squared plus y squared over a squared is equal to 1. Take the a squares on the other side, you'll have x squared plus y squared is equal to a squared. So this right here represents the curve, which I will draw momentarily, but the rectangular equation related to these two sets of parametric equations. The t has been eliminated. A unit circle with the center about the origin 0, 0 and a radius a. So given this particular equation we've developed, we know we're looking here at a unit circle with the center around the origin having a radius a. And in all instances, we're looking still at question A over here. We have a cosine 2t, y equals a sine 2t. We have to develop a graph and we have to determine the direction of this. Everything coming here from parametric equations which have a specific direction, that direction has to be determined. I'm just doing a quick rough graph over here. We're looking here at a unit circle. When I'm looking over here and that relationship, if I were to take a t value here of 0, I'll have a cosine of 0 and then I'll have a sine of 0 because this represents a value point p on any part of this curve. This point p always has an x value and a y value. Remember, a coordinate is x comma y, but x is that and y is that. When I do this, what do I get? I get at a comma 0. So my first point is really right here, a comma 0, which is right on the x-axis. Now when I take a value, let's just say a value, let's say 45 degrees, because everything has to be within that relationship, 45 degrees. Now when I'm doing that, everything is 2t, right? Isn't everything 2t? This becomes cosine pi over 2, that becomes sine pi over 2. When I now do the computation on this, look what happens to the point. The point becomes, you have cosine of 90, which is a 0, you'll have a 0 comma a. My next value in terms of this is that if I were to do here a value pi over 2, we can do pi over 2 because I'm still trying to determine the direction. Doing the graph is actually very easy because I know exactly what the graph is. When I'm doing this direction analysis, I have to just plug in these values of t's. the direction of your curve based on the parameter is always in the direction of increasing t values. See how I did 0, then I did pi over 4, now I'm doing pi over 2. It's increasing t values. When I do everything here with regards to this, I'm doing cosine now for pi, because pi over 2 times 2 is a pi, and sine of pi. And then here, you know what we're getting a minus a comma 0. So I'm getting another point here, minus a comma 0. Well, I know based on this, I have a unit circle centered around the origin with a radius equal to a. Radius is a. But now based on this little work I've done, I know I started here, then I went here, then I went here. The direction of my parametric curve based on how the parameter behaved is exactly in this. You're seeing it here in a counterclockwise direction. But this right here is not my accurate graph. I have to keep in mind this very important fact, that the period here is always 2 pi over b. What's my b value? It's 2. It's 2 pi over 2, which is pi. I have a period here of a pi, which means 2 of these waves will fit into a normal sine or a cosine wave. So the direction is good, but my graph is incomplete. My graph is really 2 turns. That's what it is, 2 turns. Not just a single turn, but a 2-turn curve. That's exactly what is represented here in terms of these parametric equations and the resulting curve. We have 2 complete turns, but they're both counterclockwise, and the arrows demonstrate that to be the case. So you can see here the question A has been solved for you. When you look at this, you develop this. When you look at the behavior of the parameter, you get the direction of your curve, which is counterclockwise for this specific case. When you do this analysis of the period, you know 2 of these will equal to 1 of your normal sine and cosine, because the period here is pi. And this question here has been completed for you. When you're looking at question B, look, x is equal to a sine 2t, y is equal to a cosine 2t. You'll go through everything in the exact same analysis. Everything will go through the same way, the same trigonometric identity. At the end, you'll still get x squared plus y squared is equal to a squared. A rectangular equation of a unit circle with the center here at the origin 0, 0, and radius here is equal to a. That's exactly what we have. So we don't have to repeat all of that elimination of the parameter procedure. All we have to do now is actually focus on the graph. Again, the graph is going to be based on this 2t, 2 curves, but we have to now determine the direction of these curves. Are they going to be still going to be counterclockwise, or will the direction change and it will be clockwise? When you look at A and you look at B, you have A cosine, here you have A sine, here you have A sine, A cosine, so everything has flipped. For any point on this very rough curve, there's a specific point, and that point in terms of x and y is always a sine 2t and a cosine 2t. That's exactly what your points are. That's exactly how the question is worded for you. If you were to put a value here in terms of 0, what will you get? You'll have a sine of 0, and then you'll have a cosine of 0. When you do this, you'll have 0 comma a. This 0 comma a tells you your start is right here, 0 comma a. So we've put in a t value here of 0 radians, and we've gotten that. Now we'll increase the value, because you always assess the direction of your curve based on increasing t values. Let's come up with a t here is equal to pi over 4 and see how everything behaves. Our point will be a sine pi over 4 times 2 is a pi over 2. And then here you'll have a cosine pi over 2. When you're doing this, cosine pi over 2 is a 0, but here you're getting an a comma 0. So as the t value increased, I came over here. I'm going to increase the t value once more, and then the direction will become clear, though already we know it's clear, but let's just do one more point. If you pick another point here and let that t value here be pi over 2, and then based on this p value, we're doing a sine of pi. Pi over 2 times 2 is pi, then we're doing a cosine pi. When you do this, what do you end up getting? Solve this part out. A sine of pi, a cosine of pi. You'll have a 0 comma minus a, and that will bring you a point right over here. And you know this parametric curve is very well established. It's going to be 2 turns, because we have again 2t. We don't have to repeat the part that the period here is pi. 2 of these will fit into one of your normal sine and cosine. This tells you clearly your period is pi. Anyhow, we have 2 turns of this parametric curve in the direction of it being clockwise, because we're going in this direction, and your curve would be like this, exactly in the arrows that you see it. And why am I starting it here in terms of 0 comma a and ending it right here? Because remember that first point when I put 0, I had a point 0 comma a established. When I put things in here, I had a 0 comma a developed. That's my start, that's my end. This parametric curve is 2 turns. 2 turns in a clockwise direction, and the period, again, as I will say it, is pi. 2 of these will fit into one of your regular sine and cosine, having a normal period of 2 pi. Anyhow, in summation, let's talk about what we've done. In this particular part A, we saw we had a unit circle developed, center about the origin, radius is equal to A. 2 turns, but it was counterclockwise. The parametric curve had a counterclockwise direction. In the second question, we had again the same rectangular equation developed, same everything, center and radius, all of that is the same. Except in this particular case, the parametric curves were 2 turns as well, but they were in a clockwise direction. Simply flipping around these sine and cosine in terms of x and y led you to these differences, as you see, in terms of counterclockwise and clockwise. But in all instances, your final rectangular equation has the parameter t eliminated, and everything has been made clear for you in this particular video. And that's gonna bring us right here to the end of this question. We have part A and part B. If you have any questions, feel free to leave them in the comments. Otherwise, I hope you all have a good day. Bye.